Okay. So I'm picking a very simple example so that you guys can see how it all works. But of course, the whole point of finding integrals numerically is for functions that we can't really integrate exactly, right? So let's pick a very simple function. We'll do x to the 4th dx on the interval from 0 to 10. Okay? So you all know what this looks like, right? Kind of like a parabola. Okay, so this is our strategy. What we're going to do is we're going to make a program to calculate this integral using the Trapezoid Rule and Simpsons Rule. And then after that, we'll also use the error bounds to see how many subsections we need to use so that we can get to the desired level of accuracy. Okay, so to do this, you can either go to the labs down in the, I forget the room it is. Yeah, so you can either use MATLAB, which is a program that they have downstairs, or you can buy it. Or, much easier, is to use this program called FreeMat, which is short for Free MATLAB. It's the same, pretty much identical, except that it's free. Okay, so that's what I'm going to use so you guys can see that you can do all this using a free program. Okay, you guys ready? All right, so check this out. So I'm going to open up a new little file here, and what we're going to do this, and this program isn't too bad. But what's happening is we're going to enter into the applied. We have 2 chapters of applied calculus, so we're going to want to enlist the help of the computer for it to do a lot of the
actual applying.
Yeah. Yes. We want to apply what we learn to real problems, right? Okay, now, what is going to be our strategy? So we have our, let me do this so that I can, I'm not quite sure how I'm going to fit all this in here, but I'll give it a go. Okay. There we go. That's what we're finding. All right. So our task is to hold on. Let me uno momento. Let me make the font bigger. Oh, I did. Okay. You guys can see that. Okay. All right. So the first thing we're going to do is we are going to set all of our info. So we're going to set the limits of integration. Okay. We're going to set our step size, the number of subsections that we want. And then I'll show you the strategy. Okay, you guys ready? All right, so A is the left endpoint, which is 0. Now, whenever you're ready to run the program, you hit this little play button. Bam! Oh, I have to save it. So I'll save it. Let's save it as, oh, sorry. Let's save it as fun times. Oh. Maybe not. Oh, sorry. Not interested in fun times there, huh? Okay, there we go. Fun times. Oh. Save in the desktop, please. Okay. All right. So whenever you want to run it, you press this little button here. Okay. All right. And then if you, and then over here it'll show you. See, A equals to 0, and then B equals to what? 10. Okay, now at some point when you run these, you have a lot of things written down, and so this gets annoying that it's printing everything on the screen. So what you do is you put a little semicolon here, so that when you run it, then it does it, but it doesn't show you anything. Usually that's better for most things. Okay, now how many subsections are we going to use? Let's start off with well, n is the number of evaluation points. So let's say we want to split it up into 11 points, which means we are going to have how many sections? 10 sections. Okay. All right. And then the step size is simply, I have the right endpoint minus the left, right? Divided by the number of subsections, which is how many subsections? 10, right? So n minus 1. You want to write this in general so that if you later change the number of subsections, then everything else gets changed too. So you have here, see if I hit play. All right, so let me ask you this. This is a quiz on the fly. Ooh, sorry. All right. If I run this, what is it going to show me? Is it going to show me those 4 things? No. No, only the last one, because all the other ones have semicolons, right? So semicolon does what you tell it to do, but it does not show you. Okay. So there we go. H is equal to 1. Does that make sense? If I'm going from 0 to 10, and I split it up into 10 pieces, each piece is length 1 long, right? Does that make sense? So it's like 0, 10, 10 pieces, right? So the length of each one is 1. Wait, there was a question, no? Yeah. Oh, okay. All right. So notice how, let's say, okay, so let me show you this. Am I going too slow for you guys? Are you like, no? No, right? It's fine. Talk to me here. Yeah, okay, all right. If I change this to 21 instead, what's going to happen? What's the size of these steps? 1/2, right? Because it's twice as many sections. So 1/2, right? Because now I'm splitting this up into 20 pieces instead, so each one is 1/2. Yes? Yes. Okay, now, this is our strategy. Now, to be able to use the Trapezoid Rule or the Simpsons Rule, we need the y values, yes? That's all we need, the y values of our function. Okay, so to find the y values, well, we need the x values, right? So like right here, these are the x values, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Okay, so this is what you do. You say, okay, I want you to make me some x values. I want to start at A, and I want to go all the way up to B. But I want to specifically go in a step size of h. So what do you guys think that's going to do? How many x values is that going to give me? Whatever n is, right? So if we go back to n equals to 11, this would give me 11 x values, right? So hit play, bam, 11, right? 0, 1, 2, 3, 4. So start at 0, end at 10, 1 in between each one. Yes?
Can you make the font a little bit bigger?
Oh, yes. I can. Let me see. I'll just go into my settings, font. Oh, that. Oh, okay. I don't know if I can make this one bigger, though. Font. Ooh, sweet. Look at that. Oh, okay. All right. All right, now if I go back here and I change this to 21, what do you expect x to be now?
21.
How many points?
21.
21, right? Look at that. Starting at, now my font is kind of big. Maybe I'll make this one a little smaller because it's kind of too big. Okay, so see how it goes from 0 up to 10, but now each one is half in between each one, right? Okay, then I need my y values. So then all I have to do is I say, okay, y is equal to x to the 4th. That's my function in this particular case, right? Ooh. Okay, so then what that's going to do is it's going to grab each one of the x values, and then it's going to raise it to the 4th. Okay? So all of these x values, it will raise them to the 4th. But there's a small problem, because I hit bam. Oh, no, error. Oh. Okay, so this is something that you'll learn later. But for now, I will show you that what this is the x is it's a vector. So when you raise it to the 4th, you're doing vector multiplication. And depending on how much you guys remember about vector multiplication, you cannot multiply a row vector times a row vector. It has to be row times a column. So what you do, this isn't really what we wanted to do. we wanted to multiply each one of the x values by itself 4 times. Yes? That's what we wanted to do? Okay, so all you have to do, instead, is you just have to tell it, okay, I want you to do element by element exponent. And so you put a little dot there. So all that does is it changes it to grab every single element and then raise that to the 4th power. Okay? So it'll grab, instead of doing vector multiplication, it'll grab each element individually and raise it to the 4th power. So you give it an x value, and it'll raise it to the 4th. So like, for example, the first value of y would be 0 to the 4th, which would be 0, right? Yep. What would the second y value be? 1. The third? 2 to the 4th, which is 16, right? Okay. So let's bam. Oh, whoops. Sorry. We're back at 11. We want to be at 11. There we go. We were at 21 points. So this makes sense, right? So this is 0 to the 4th, 1 to the 4th, 2 to the 4th, 3 to the 4th, 4 to the 4th, and so on and so forth. Yeah? Okay. You guys good? Okay. So those are all my y values. And then, okay. Now here comes the fun part. So what we want to do, let's go back to, okay. Let's go back here so that we can write down some things. So remember the trapezoid rule. Ooh, let's do this. The trapezoid rule is equal to 1/2 times delta x or h, and then we have y0 plus y1 plus y2. Sorry, 2y1, 2y2, dot, 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 all the way to 2yn minus 1 plus 1y sub n, right? That's the trapezoid rule. Okay, so this is our strategy. You guys ready? So notice that what I want to do is I want to multiply the all the middle y values by 2, and except for the first and the last, I want to leave them alone, right? And then I want to add all of them up and multiply it by 1/2, and then h. Yes? Okay. So what we're going to do is we are going to tell the computer to do this, we're going to create a vector called, let's call it A. And this will have a 1, a bunch of 2's in the middle, and then a 1 at the end. And then what do you think we're going to do with that vector? We are going to multiply it by the y, right? So what's going to happen is the first y value is going to get multiplied by 1, all the middle ones by 2, and then the last one by 1. Yes?
Yes.
Okay, so that sounds good, right? All right, so let's go back here to our little program. This is all very simple. This is what you do. You guys ready? You're going to use a new command that you will learn just in this moment here. Hold on. Okay. You're going to use the ones command. Okay? So the ones command creates a vector or a matrix of ones. So if I say A is equal to ones, for 1 to n, that creates a 1-row n column of the number 1. So not exactly what I want, right? I want, so let me hit play here. So ones, right? So because n is 11, then A is 11 ones. But I want all the middle ones to be 2's. So instead what I do is, okay, I'm going to multiply it by 2. And what do you think that's going to do? All of them are 2's, right? Okay, but that still isn't exactly what I want, right? I want the first and the last to be 1. So what I do is I tell, okay, after all of them are 2's, I want the first one to equal to 1. And I want the last one to equal to 1. So if I run this, what do you expect will come out?
1, 2, 2, 2, 2.
Yeah. So exactly what I just had, except that all of the ones, the first one and the last one are going to be 1's, and then all the ones in the middle are going to stay 2's. Yes?
Can't you just make it like 1/2, like from 1 to n, like make that 1/2, so then 2 times 1 would be 2 times 1/2 would be 1. that make
You can do it a lot of different ways.
Okay.
But
Let's do that.
yeah, if you want to mess around and play and do it different ways, yeah, that's totally fun. Fine and fun, both, same time. Yes, Whitney?
So the equation in line 7 still applies.
Which one?
Like, you know how you said 8 equals 2 times 1? Does that still apply? Like, how does it?
Mm-hmm.
Oh.
Yeah, we keep that one, right? So we don't do anything with it. We leave that one there. And then all we're saying is we want to change the first one and the last one to the number 1. That's what we want to do. Then what we do is we are going to multiply that times y, right? So if I multiply this, and remember I have to do a dot multiplication because I want every single element by element, right? So the first one with the first, second with the second, third with the third, fourth with the fourth. Otherwise, it does vector multiplication, which is different. So if I multiply a and then the dot times y, what will that do?
Don't you need to
I put the dot. Yes, each element in A multiplied by each element in y, right? Okay, so first times first, second times second. Oh, sorry. Sound effect came too quick there. So, and then what else do I want to do? What do I want to do with those values? If I look at my formula, you want to, besides from divide, well, because we look back here, right? So what I just did is, what I just wrote down is this I've created these values, but they're all inside of a vector. What do I want to do with them? I want them to be added up, right? Don't I want to, so all those numbers that I have, I want them to be added up and then multiplied by half times the step size, right? Oh, I need that. Okay, so then we go. So I want to add them up. So what you do is you do the command sum and then parentheses. So this adds them all up. And then I want this to be multiplied by 1/2. And I also want it to be multiplied by the step size. So how many numbers should I get if I do that? Only one single number, right? And that right there is the, I'll call it T for the trapezoid rule. Let me do this. CLC clears the screen, so it'll clear the screen every time. There it is. That's the, what is that number right there? Approximation to the area under the curve of x to the 4th from 0 to 10 using trapezoid rule with how many subsections? 10 subsections, right? 11 evaluation points. Okay. Now what's the exact value? Well, it's easy to find, right? So it's x to the 4th, right? What's the antiderivative? Let's do this for fun. All right. The exact value is equal to, in this particular case, right? It's equal to, so the antiderivative is x to the 5th over 5, right? And we're going from 0 to 10. So this means that it would be the number 10 to the 5th and then divided by 5, right? Yes? And then minus 0 to the 5th over 5, which is 0, right?
The dot there.
You don't have to put the dot with numbers. When you're just working with scalars, you don't have to do it. It's only for vectors. So you can put it, it won't change it, but you don't have to. That's why I noticed there's no dot right there after the 1/2, because 1/2 is just a number, and h is just a number as well, so you don't need the dot there. But if you put it, it won't. It'll do exactly the same thing, so it doesn't matter. So what do you guys think? Pretty close? So how would we get to closer to that exact value? More subintervals, right? So let's say I do 101, let's say. Better or worse? Better, right? Better, right? So this wrote it funny, but That's okay. So it's times 10 to the 4, which is basically 2,000. What is it? 1, 2, 3, 4? 20,003, right? That's what it says? Oh, shit. Whoops. Okay. All right, so let's say I do 1,001. Bam. There we go. 20,000. So for some reason I decided to put it in this form. I don't know how to make it not do it at this exact moment. Does that make sense? Yes.
So it's going to be, the extra is 333, and it's going to move it this way every time you add it.
Yeah, because it's the e plus means times 10 to the, and then whatever this number is. So it's this number times 10 to the 4. If I write in here, if I want more decimal places, you type in format long. Oh, great. Long. Okay, and then if you do the same thing, it just gives you more decimal places. So then you can kind of see, right? So the exact answer is 20,000. This is times 10 to the 4, so 1, 2, 3, 4. So this is giving you 20,000.033333333. So far, so good? Okay. Now, all right, so let's do this. Let's go back to 11 again. And let's use this same strategy for Simpsons Rule. Okay, you guys ready? So using the same strategy, Simpsons Rule is, instead of all these 2's, right, I want to have, let's call it B. I want 1, 4, 2, 4, 2, all the way up to 1, right? But everything else is the same. So the only difference here is I need to somehow create a vector, let's call it B, that has 4, 2, 4, 2, 4, 2, 4, 2. All right, so here is what you do. Let's do a vector of 1s from 1 to n. And then, so check this out. This is, so I want starting at the second one, I want it to equal to 4, right? But it's 4, 2, 4, 2, 4, 2. So what I want it to do is starting at the second one, in steps of 2, I want it to go all the way to 1 before the last one, and I want that to equal to 4. Okay? So take a look what happens. Boom. So it was starting off as all 1s, but then from the second, in steps of 2, I want them to all equal to 4. Thumbs up, huh? Yeah, totally. Now, okay, so take a look. Now I want the other ones to be equal to 2. So what would I say? B starting at the third in steps of size 2 all the way to, yeah, n minus 2. I want those to equal to 2. Booyah. Look at that. And you can change the size, right? So look, take a look. Oh, if I want 101, bam. Look at that. 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4. I can do this for a million, right? And see, the last one is still 1. Awesome. Just awesome. Now, okay, so then, oh, this is so exciting. All right, so don't forget, so Simpsons Rule, let's call it S. So what am I going to do with this B? I'm going to multiply by y, right? Just like I did for the other one. Okay. What do I want to do with all those values? I want to add them up. Add them all up, just like I did for the Trapezoid Rule. Okay, but then Simpsons Rule, remember, on the outside, we multiply by not 1/2, but 1/3 times h, right? So 1/3 times h times that sum, and lo and behold, bam. Wait, sorry. Okay, bam. What is that? So if you look, so this is only with 11, right? Notice how the exact answer is 20,000. Trapezoid Rule is 20,333, right? So But Simpsons Rule is much more accurate, right? Simpsons Rule is 20,001. It's only off by 1, whereas Trapezoid Rule is off by 333. And that's with 11. If I make it 101, what do you expect? Greatness, right? Greatness and accuracy, right there. Look at that. Look at how much closer Simpsons Rule is. Way better, right? Yes?
Why are we doing this?
Because no, well look, okay, so now check this out. Look. Okay, so instead of x to the 4th, all right, so I have sine of x over x, which I have no idea what it is equal to, right? With a flick of a pen, bam, that's the integral of sine of x over x from 0 to 10.
Hey, but they're the same. Oh, yeah.
Well, that's because I have a lot of, a large number of subsections, right? If I make this shorter again. Now, the only difference here is that I don't know exactly how many, right? They're not the same. It's just,
Oh, no, they are the same.
it's just trapezoid. No, if you keep looking, look at, hey, why are they the same? What?
I don't know, but you just proved the trapezoid rule is just as equal.
What happened?
You did something.
It's Alvarez's rule now. Add Simpsons rule.
It's just that this function is different or something. I don't know. Let's make some more stuff up here. What happened? I don't get it.
Okay, so if we get them equal to each other on the homework, we're good, right?
What is happening here? Oh. No, this is messed up. Oh. Oh, that's why.
You
Wait.
should fix that before you pick it.
Oh, that's because, yeah, I messed this up totally.
Okay. Yeah.
This one's messed up because that.
Oh.
That's why I messed up. So the reason why is because sine of x over x, it was supposed to be dot slash, and that's why it was coming out. Because it turned out to be just a number.
Then why do we have to change the interval from 1 to 10?
Because sine of x over x is undefined at 0.
So then it just made it unavailable.
Well, no, it says not available.
Have a good weekend.
have a good-
Make nice math videos. That's what he does. That's what he does. He does it.